Hello class, today our topic of discussion is Rolle's Theorem. Now we look at first the statement of the Rolle's Theorem, which says that suppose we have a function fx, a real valued function in a closed interval ab. Real valued function means if you take any value from a to b including a and b and you put it over here, you'll get a real value. Okay, and if it is continuous in closed interval AB, which means if you draw the curve from A to B is continuous, there is no point of discontinuity from A to B, and if it is derivable in open interval AB. Now derivable in open interval AB means we have not included the point AB. Why? Because at the point AB we'll get multiple tangents. Okay, so we have excluded the point AB. So the function is derivable in open interval AB, and the third condition is if FA is equal to FB, then there exists at least one real number C in open interval AB such that f dash C equals to 0. Now look carefully, f dash C equals to 0. F dash C is nothing but the slope of the curve at x equals to C. And the slope of the curve we are equating with 0, which means if you draw a tangent to the curve at the point C, then it will be parallel to the x-axis. So that is the statement of Rolle's theorem. Now we'll look at the geometrical interpretation of Rolle's theorem. Now look at the geometrical interpretation. Now three cases may arise. Okay, since the curve is continuous and this is your point A, this is your point B, so you can get a curve like this, you can get a curve like this, or you can get a curve like this. Look over here, FA equals to FB, over here FA equals to FB, over here also see FA equals to FB. The curve is continuous, it is derivable at any point between A and B, you will get a tangent. Okay, then there exists an FA equals to FB, then there exists at least one point C such that f dash C equals to 0, which means, see, at least there will be one point C where the tangent if you draw will be parallel to the x-axis. See over here, over here you will get 2 points, C1, C2. I told you at least, which means you can get more than 1 point. So this was the geometrical interpretation of Rolle's theorem. Let us take an example. Okay, before going to the sum, few things we should know beforehand, that a polynomial function, exponential function are always derivable and continuous, and trigonometric function, inverse trigonometric function and log function in their respective domain are differentiable as well as continuous. Now look at this sum. First, since it is a polynomial function, we can say that it is fx is continuous in closed interval 1, 4. Okay, we don't need to prove this. Okay, second, fx is derivable at open interval 1, 4. If you derivate this function, find the differentiation, you put any value between 1 and 4, you'll see that it will exist. Okay, it is derivable at any point between 1 and 4. The third, we'll find f of a, that's f of 1. F of 1 is what? 1 square minus 1, this is 0. And f of 4 is what? 4 square minus 5 4 is 20 plus 6, that's again 0. So fa equals to fb. Then there exists a point C such that f dash c equals to 0. First find f dash x. Now f dash x is what? 2x minus 5. So f dash c will be 2c minus 5, which means 2c minus 5 equals to 0, which means c equals to 5 by 2, which lies between 1 and 4. Hence, at this point, the tangent will be parallel to the given curve. Let us see sum number 5, part 3. Verify Rolle's theorem for fx equals to e to the power 2x sine 2x minus cos 2x. Interval is given. The first thing, we know that exponential functions are continuous and sine and cosine are continuous in the given domain, which means fx is continuous in closed interval pi by 8 comma 5 pi by 8. Is derivable also. Fx is derivable in pi by 8 comma 5 pi by 8 open interval. Now we'll find f of a. So f of pi by 8 will be e to the power 2 pi by 8 is pi by 4, yeah, and this becomes sine 2 into pi by 8 is pi by 4 minus cos, similarly pi by 4. Now we know this is e to the power pi by 4 and this is 1 by root 2 minus 1 by root 2, that's 0. Let's find f 5 pi by 8, so that becomes e to the power 2 into 5 pi by 8 is 5 pi by 4. Similarly, this becomes sine 5 pi by 4 minus cos 5 pi by 4. Now e to the power 5 pi by 4. We know how to find the value of this. We have already done this in class 11. Sine 5 pi by 4 can be written as sine pi plus pi by 4, which is minus sine pi by 4, which is minus 1 by root 2. This is minus 1 by root 2. Similarly, cos 5 pi by 4 will be minus 1 by root 2, which becomes minus becomes plus 1 by root 2, and this becomes 0. Now we see that all the three conditions of Rolle's theorem are satisfied, which means there exists a real number c such that f dash c is equal to 0. Let's find f dash x. F dash x is what? We'll differentiate this first function. Now ddx of second function means sine 2x will be 2 cos 2x minus cos 2x will be minus 2 sine 2x plus second function and ddx of first function, which means e to the power 2x will be 2 e to the power 2x. Now you look carefully when you open the bracket, cos and cos term gets cancelled, 2 sine 2x and over here 2 sine 2, which means it will be ultimately 4 sine 2x e to the power 2x. So f dash c is nothing but 4 e to the power 2c sine 2c. Now this will be equal to 0, implies 4 e to the power 2c sine 2c equals to 0. Which means I can say that sine 2c equals to 0, which means I can say 2c equals to pi by 2. Yeah? No, we can say that 2c equals to pi, which means that c equals to pi by 2, which clearly lies between pi by 8 and 5 pi by 8. Hence this is the required real number. Okay? Now we look at the next sum. Now look at this sum. They have told verify the condition of Rolle's theorem and find a point in the given interval where the tangent to the curve is parallel to the x-axis, which means we need the point, the value of x as well as y, where the tangent is parallel to the x-axis. Okay. Now look, first point, since it is a log function, we can directly say that fx is continuous in closed interval this. We don't need to prove that, okay? Second point, again fx is derivable in open interval this. Third, we'll find f of a. F of a is log, this is minus 1 square becomes 1 plus 2 minus log 3, and this becomes 0. Similarly, f of 1, this becomes log, again 1 plus 2 minus log 3 equals to 0, which means all the three conditions are satisfied, which means there exists a point C such that there exists at least one point C such that f dash C is 0. Now look carefully. First of all, f dash x, this is log, we know by chain rule, this becomes 1 by x square plus 2, and x square differentiation is 2x. So this is, and this is 0. So f dash C is 2c x square plus 2, c square plus 2, and this will be equal to 0, which means 2c c square plus 2 is equal to 0, which implies c is 2. We got the value of c. We need to find the coordinate, okay? Suppose the curve was this is your c. We need the corresponding value of y also, y coordinate also. Just put the value of c over here. So y will be what? Log 0 plus 2 minus log 3. That's log 2 minus log 3. That's log 2 by 3. Which means the point will be what? 0, comma, log 2 by 3. And that's my answer. Is it clear? The point is this. And we have verified the Rolle's theorem. Now we'll look at one more sum from this chapter. Now look at this sum. Okay, this is sum number 8 from AGGARWAL. If Rolle's theorem holds for the function, they have already told that this function holds Rolle's theorem. Fx equals to x cube plus ax square plus bx in closed interval 1, 2 at the point x equals to 4 by 3. We used to find C. That point is given, okay? Find A and B. Now, we already know that Rolle's theorem is verified. So, can we say FA equals to FB? Which means f of 1 first you find. That's 1 plus A plus B. And f of 2 you find. That's 8 plus 4A plus 2B. Now, these two will be equal because Rolle's theorem is verified. Which means I can directly write 4a plus 2b plus 8 is equal to 1 plus a plus b, which means 3a plus b plus 7 equals to 0. Now, since Rolle's theorem is already verified, we can say that f dash c equals to 0. First find f dash x. F dash x is 3x square plus 2x plus b, which means f dash c will be 3c square plus 2c plus b. C's value is this. You can directly put x value over here also. So f dash 4 by 3 is 3. 4 by 3 whole square plus 2 4 by 3 plus b. Is it clear? Which means this is 16 and 3 and 9 cancel, so 3 plus, and this is oh, we missed something. Wait, I think I missed a over here, ax. So this will be 2ac plus b, which means this will be 2 4 by 3 a plus b. Is it clear? So that's 8 by 3a plus b. Now we know that this has to be 0. F dash c is equal to 0, which means 16 by 3 plus 8a by 3 plus b equals to 0, which means 16, if you take LCM, equals to 0. Now look, we have two equations. You can solve it simultaneously and get A and B. Okay, so this was Rolle's theorem.